all of us are doing fine. My name is Ernest, and this is Ernest Sciences and Mathematics TV channel. In this particular discussion, I'm going to look at the concept of a comparative study of S and P block elements. And this is going to be forming our introductory part, where we're going to look at basically the concept of the periodic table and some of the periodic trend. In this case, this is going to assist us understand the overall aspect of different characteristics of this specific category of S and P block elements of the periodic table. And in this case, this is going to be more specifically relying on the concept of specific characteristics insofar as their chemical and physical properties are concerned. This is going to be exhibiting some unique characteristics across specific, of course, periods and down various types of groups, as we're going to see. Now, in our introductory part of the concept of the periodic table, I had mentioned that we can categorize the periodic table into two specific sets, which are going to constitute families, or what we refer to as groups. And of course, these are going to be basically columns which are going to form a specific set of elements. And then we're going to look at the concept of periods, which are going to be forming what we call rows of the periodic table. Now, the periodic table, as I had mentioned from our of course, previous video on the overview of the periodic table, I had said that it's organized in an array of elements depending on their mass numbers. And of course, this is also going to be taking note of their specific properties, which are going to be physical and chemical properties in that particular sense. Now, from the historical context, I mentioned that basically there were various works which were, of course, done by a number of scientists or a number of individuals who came up with the specific rules which we're going to use in trying to, of course, categorize elements in various parts of the periodic table. And these were the works of Dmitry Mendeleev, to mention but a few. We're going to see the works of Dmitry Mendeleev and Henry Moseley, and also we're going to look at the works of course, Lothar Meyer, and also the works of John Newlands. And of course, among other scientists, we're going to see that these specific individuals are going to contribute basically in trying to organize the periodic table in terms of mass numbers and their specific properties, which I've mentioned, chemical and physical properties. And in this case, therefore, this is going to dictate on which row or column these particular elements are going to form. And of course, that's going to give us a sense of specific arrangements which we are going to witness across and down the specific columns which we are going to see in the periodic table. Sorry for that. Now, in our last discussion, I mentioned the concept of periodicity, and said that this is going to be a characteristic, repetitive form of patterns which are going to be witnessed, of course, in the periodic table. And this, of course, are going to be properties associated with the increasing atomic weight and also the physical and the chemical characteristics, as I had mentioned. Now, these repeating patterns are going to provide for us a basis for the definition of the periodic law. And as I had mentioned, of course, we're also going to see the concept of the laws of octaves being defined from this particular trend. Now, we had mentioned that the periodic table can be categorized in terms of this physical and chemical characteristic. And we had said that, of course, we're going to categorize this one in terms of the S and the P block elements, which are going to form the main elements of the periodic table, as we're going to see. Perhaps I'm going to give an illustration on that, and then we're going to see these specific elements being defined as the D block elements in that particular case. And these are going to constitute a range of elements, especially which are going to be contained in the, of course, these are going to be the transition elements. And of course, also we're going to witness another category which is going to be defined as the F block elements, which are going to basically constitute the inner transition elements, sometimes which we are going to refer to as the lanthanides and actinides. So in this specific case, I'm going to give this one perhaps in terms of illustration, which is going to assist us basically try to define these particular elements. But in a sense, we said that the classification of these particular elements in terms of S and P block elements, D or F block elements are going to be dictated by their valence electrons. And we had also looked at the concept of giving these specific elements of the periodic table and electronic configuration, which was dictated by specific rules. Now, in a sense, I've mentioned that for us to assign a specific electronic configuration to elements in the periodic table, we're going to follow particularly the three rules, which constituted the Hans rule. And of course, I've mentioned the concept of the building up rule, which was the Aufbau's principle. And then I mentioned about the Pauli's exclusion principle, which formed the basis for trying to define some specific arrangement of elements in the periodic table. Now, there's a particular trend which we are given in a sense that we can be able to give a shorthand form of this electronic configuration by use of what we refer to as inert elements, or the group 8 elements of the periodic table, which basically constituted the inert gases, of course, which, of course, I had said constitute group 8 elements of the periodic table. Now, in this case, I'm going to have just a rough sketch of this display of various categories of elements which I've given, and that's going to provide for us in a sense of specific categories which I've mentioned depending on the SPDF, of course, kind of representation of the periodic table. And this particular illustration, I've basically drawn a rough sketch of our periodic table, and this is going to range from the group 1 to group 8 elements, which are going to be given in this particular order. Now, therefore, for this first specific elements, which are categorized as 1s, and the last one as of course, s given as such, we're going to see that this can be given in terms of we can assume that this specific element was forming a set of this particular category of the S block, which are going to be given as such. Now, the combination of S and P block elements, which are going to be shown on this periodic table, are going to form what we call the main elements. And as we said, these are going to constitute the S and P block elements, or the main group elements, which are going to constitute the S and P block elements given as such. And in this case, I've mentioned about the second category, which is going to be constituting the P block elements. And these are going to be basically forming a range of elements for these outer transition elements given as this one for the range of 3D to 6D given as such. And of course, there are other inner transition elements which are going to be given in terms of 4F and 5F. And basically, these are the inner transition elements that we're going to come across in the periodic table, perhaps categorized as the lanthanides and actinides in that specific range. Now, in our next discussion, we're going to look at various, of course, characteristics of these particular elements, especially on the trends of the columns and rows, which we are referred to as families. And follow us in the comment section of this specific video on this specific discussion. So that is it for now, guys. By God bless you. Catch us in our next video.